All right, we'll get started. Thanks everyone for coming to this talk. We're going to be talking about classes and broadcasts, the building of a PowerShell module for the Windows visual settings. I want to start out by thanking our sponsors, without whom, of course, we wouldn't have this great event. My name is Arnoud Jansveld. I come from the land of tulips and cheese. But I currently live and work in the New York metro area. I've been doing PowerShell for a very long time, still learning, but I'm a systems engineer at Jane Street. Hopefully you've had a chance to talk to some of us here at our booth. But at Jane Street, we're a trading firm. I've been around for about 25 years, and we love to automate. So in the IT department where I work, we have over 100 people that are all using and writing PowerShell. Last time I checked, I'm sure you've heard me say this already one of these days, we had about 500,000 lines of PowerShell code, about 185 modules probably, and counting. So we're very invested, I guess, in the platform. We started doing our own training to get all these people, really get their skills up. We do, of course, code review and all of these great things. So great place to be. If you have any, if you want to know more about Jane Street in general, please come see one of us at the booth outside. So what are we talking about today? We're going to talk about the making of this PowerShell module to manage the visual effects in Windows. And you might have a use for this. But even if you don't, we're going to talk about kind of like how this was put together. So there's some concepts in there that might be applicable in other cases, specifically about Windows broadcast messages and a little bit about PowerShell classes. So what are we trying to do here? We actually had a need to manage these visual settings. If you remember this lovely GUI dialog, anybody recognize how old that is? Yeah. It's actually Windows XP. It's changed a little bit. So some of the settings have, new settings have been introduced, but that's basically been around for a very long time. Why would you want to do something with these settings? So these are like things like animations, fading in and out, drop shadows, font smoothing, and all these kind of things. They look great. But if you really need the performance, people generally want to turn these things off. So a lot of our users, they just want the absolute fastest thing they can get. And especially if you're in any kind of like a remoting scenario, Citrix, VDI, remote desktop, they typically recommend to turn these things off because it just all takes up more bandwidth and more delay. All right, well, that's all well and good, but we want to script that, right? We're at a PowerShell conference. So we wanted to have this. We wanted to be able to set these settings for our users and do it in code. I looked around, I figured, well, this has been around for this long, like somebody must have figured this out already. And it turns out it wasn't that easy. So this is what we wanted to accomplish. So we wanted to be able to make changes and make them take effect immediately. The GUI dialog does that, so it seems to be possible. We wanted it to be flexible, so different sets of users, we may want to give them different settings. We want some presets so that it's just easy to give people kind of like a consistent baseline for these settings. And we wanted compatibility with PowerShell 5 and later. So, of course, the first thing you do is you go look on the internet and see what people have done. There's a lot of the pages and pages have been written about this, but it basically all boils down to either a bunch of registry edits, group policy, which in most cases is just the same thing as registry edits, and modifying the default user profile. Now they work, but the big complaint then is if you follow all these threads on Stack Overflow and other places, is that people always say like, yeah, but I don't want to have to restart Explorer. I don't want to have to like log off or restart my computer to get these things. So that's the problem. So for these changes to take effect immediately, just changing the registry doesn't cut it. If you modify the default user profile, then yes, the first time that user logs on, they do get those settings immediately, but it's not very flexible. Right now it's like one size fits all, and it's really only for new users, or at least new profiles. I guess it's worth mentioning that these are user settings, right? So you have to set them in the user context. Everybody with me so far? Okay. All right, so we know the registry is involved. I guess that makes sense, right? These settings, they persist across log-offs and reboots, so they must be stored somewhere. So let's find out what these are. So as most of you have probably all done at some point in your life, you know, you fire up this guy, Process Monitor, Procmon, right? The good old tool. I'll fire up the dialog box, which has a not very convenient name, but thankfully we have tab completion, and so there we are. Doesn't look as snazzy anymore as that XP version. I kind of like that one. So I've filtered this instance of Procmon here because, you know, if you just turn it on, it'll give you just a gazillion entries. I filtered it on this particular process, and I've filtered it on just registry writes, just to make it a little bit easier to see what's happening. So if I change one of these settings, make sure this is turned on, you see that, okay, I'm getting my data back. I can see what registry entries are being touched, which is, of course, what probably all these people that have written about this over the years have probably done something similar. I can even say like, all right, let me turn them all on, and I get all those registry entries. We'll maximize this. Just wanted to point out that, okay, so I've got all these different keys and values. I can see the data, you know, so I can turn these things kind of like on and off one at a time and see exactly what's happening. One thing that's worth pointing out is this user preferences mask is a binary array. So bits are getting turned on and off. So not very convenient. You see, you know, people have tried to tackle this in a variety of ways, hard coding, like turning bits on and off. So that's not great. But at least we know one part of what we need to touch. I'm just going to turn this. Actually, we'll just leave this where it is for now. All right. So we know the registry entries that we need to touch. But we also know that that's not the whole story. So what's the other piece there? What are we missing? Why are these things taking effect when I change that registry entry? So we want to look for an API. There must be some kind of Windows function, right, that this dialog box is calling. And so let's look for that. If you Google around, you know, you kind of, it's almost like, you know, prompting. You have to get the right search terms in, but you will land on this system parameters info function. If we look that up here, is this guy. It's a long page, has a lot of information, but it's a kind of a low-level function, right? This is typically used from C++. It's unmanaged code, but it looks promising because it does talk about UI effect parameters and a whole bunch of other things that can be turned on and off. So I think that's where we want to go. There's a long list here of all the different settings that it can touch. It's basically just all indicated by this one hexadecimal number that indicates which of these things we want to touch. And that's going to be important. We'll see that later in the code. So great. So we have this C++ thing, but we want to write PowerShell. So how do we do that? Who knows how do we do that? Who's used pinvoke in their code? All right, a few hands. So, and even if you haven't written it, you've probably seen it, right? So this is a pretty common thing that you'll find. So we need to basically take this low-level function, we need to get a little bit of C#, basically a signature in C#, and then add that to PowerShell with add type. You don't have to like invent this yourself. There's pinvoke and there's pinvoke.net, which basically describes for all of these low-level functions how you need to express that in C# to be able to use it from managed code. So I've looked up the system parameters info function here, and it basically gives me these signatures. Okay, so we're one step closer. We're still not in PowerShell yet, but we'll get there. Before we actually look at the code and see how we can now use this, I wanted to point out one thing. In the very bottom of that page, we'll just call it SPI, System Parameters Info, they mention this parameter that you need to pass, and it talks about two things. It talks about whether the setting is persisted, whether it's being written to the registry, and whether it is going to send a broadcast message. Now, of course, there it is. Okay, so this broadcast message is the secret to getting these settings to take effect immediately. You can look this up. You know, they actually have a link here to this WM setting change that I guess is the specific message that it sends. There's a whole page of documentation on that. It's a message that has some parameters that indicate what type of thing has changed. All right, so let's try this out. All right, so here's the kind of like the smallest bit of code to test out calling one of these APIs. As you can see here at the very top, we've got that signature that we get from pinvoke. We added with add type, so that makes this kind of like custom type available on the fly to our PowerShell code. We set up a couple of constants here, variables with that Win32 parameter. That's the one that is going to say like, okay, I will send the broadcast, and then I've just picked one of those settings from that page. I'm going to see what that does. So I'm going to run this. I've put a breakpoint here so we can step through the code and see what happens. Okay, so this first call here, if we run this, you can now see like, oh, I have mouse trails. And call the same thing again with a different value, basically 0. Now my cursor is normal again. All right, so that looks promising. So I can make changes on the fly. Here's another one, drag full windows, just to show what I mean by that. So if you move a window around, right, you see its contents. So it's already on, so this first thing will not do anything. But if I call it the second time with basically a Boolean of false, now I just get the outline. Okay, so that's one of those performance settings. Okay, great. So we found the API, we figured out how to call it from PowerShell, and we've learned something about broadcast messages. So you can go through that page, find all these settings, see where they match up with that graphical dialog box, because that's basically what we set out to do, is we just wanted to like have the exact same settings in code. It turns out that not all of those settings are actually available in this API. So we need to find out a little bit more about this other class. Okay, we know that the registry is still involved, and you can kind of guess that the broadcast messages probably also play a role. So how can we see these broadcast messages? I looked around to see if there was some kind of tool that did this. The only thing I found was a thing called Spy++ that ships with Visual Studio. It does show a bunch of these Windows messages that are being passed around, but it's missing one piece of information, because this particular WM setting change one passes it as one of its parameters a string, and you can't see that string with that tool. Okay, so we'll have to write our own. So that's this guy. Show message. Tried to keep it as simple as possible, but I did have to cheat. You need some more C# to make this happen. Couldn't do it all in PowerShell. It instantiates a Windows form that's just hiding in the background, but that's the thing that will receive these messages and then pass it back to PowerShell. So this is kind of like a custom, it adds some extra methods and event handlers. By the way, I'm not a C# guy at all. I hacked something together that worked, and thankfully a colleague of mine helped me clean this up in something that I wasn't afraid to present here. The PowerShell bit here is very short. It really just takes the data that's being passed back from that form and just displays it in a way that I can understand. So let's run this. I'll put this here to the side. And here's that script. And it's just going to listen for messages. I pull up my nice little dialog. Let me just turn on or turn off one of these things. Okay, so I'm getting some data back. So you can see it's giving me two parameters. One is a number. I don't yet really know what that is. And then a string. It's actually really passing a number again. It's a pointer to a string, but that's what the code does. It basically decodes that and gives me the string back, which is useful in this case. If I went, just turned all of these things off, well, except I still like my fonts to be nice. So I get a whole bunch of broadcast messages back. Okay, so this is great. So now I know how to find the registry keys that are being set, and I can find out what kind of broadcast messages are being sent. So I can, again, turn all of these things on one by one, turn them off, and see what's being sent. If we look a little bit closer here, you see that actually there's numbers being passed here as this W param. And those numbers conveniently line up exactly with those numbers that we were passing to the API. So that makes life easy. But you can see for that second parameter, it sends different messages depending on which setting I'm touching. By the way, it's kind of cool to just let this thing run for a while and just go about your day, and you actually find that their messages come in. There's a thing that will I guess notify Windows when environment variables change, when your culture settings change. So it's kind of fun to just kind of see that happen. Great. So now we have the data that we need. We know this SPI function that we need to call. We've learned, figured out how to use pinvoke, and we've learned about these broadcast messages. So just to, I guess, make it clear, I talked about the two different types of settings, right? So some of them we can access directly through this API, and the other ones I could not find an API or any kind of thing like that to set them, but we're just going to set them in the registry and then send the broadcast message that we've learned from monitoring what the GUI dialog does. Great. So I've shown you the API call, right, or at least the basic version of it, and then how we visualize these broadcast messages. So it's time to actually put it in code. Any questions so far? Anything that's not clear up until this point?
I had one thing. I noticed on that last slide, some of the effects that showed up, I didn't actually have the string for them, and some of them did.
Yeah, so the question is, when we monitor these broadcast messages, some of them have a string attached apparently, and some of them don't. Yeah, that's exactly how they come through. I think that second parameter is just 0 in that case. So specifically for these API calls, apparently they send a more specific broadcast message saying, okay, this is the number of the thing that has changed, and nothing further. The other thing maybe worth pointing out is that if you change a bunch of settings here through this dialog box, it doesn't send like the same broadcast message multiple times. So it kind of, if a bunch of them would send this visual effects message or this shell state message, it will only send it once. So apparently it's doing, collecting the various broadcast messages that need to be sent and just sends them once. I also want to point out that turning on or off these effects sends the exact same broadcast message. So it doesn't actually tell you that much about exactly what changed or whether it was turned on or off. It's more of just a signal saying like, hey, something changed. It's like, somebody hit the car horn. Like you don't really know what it's for, but you pay attention, and I guess these windows will then do whatever is necessary to adjust their behavior. All right, so let's take a look at the code. So I'll kind of describe this. I mean, the code, by the way, is open source since this morning, so you look at it, but I'll point a few things out. This file right here is just all of those pinvoke signatures that we need to call these APIs. That system parameters info function has a few different permutations based on the type of the parameters that go in and out. Actually, I'm going to take one step back here. I wanted to just show you one other thing. And this is really kind of like the philosophy around putting together the code for this type of situation. And I'll explain why I decided to use classes. I typically don't use classes that often. I think for the most part, PowerShell, advanced functions are easy to work with. Users understand them. You can get help, and the pipelining and all of that is well understood. Classes, I think, are useful, well, for developers because they're used to working with classes. But in my experience, they kind of come in handy in two cases. One is when you're trying to describe some kind of data shape or data format. You're getting data in from some other external source, for instance, or you want to output it and be very strict about what shape, what properties that has. It's great to use a class for that. It gives you a very nice description of all the properties that are there. You get like validation on the property types, etc. And then this is the other case where I thought it was useful. We can use class inheritance to make our code simpler when we're dealing with these different types of effects. So I have two different types of effects that need a different way to get and set them, but that can get a little complicated if you're trying to put that into code. So I have some pseudo code here to try to describe that. So let's say that I've written some functions to get and set each of these types of effects, right? So I must have like a list somewhere of all the, let's say like all of the API-based effects. And I'm gonna have to decide, okay, well, if it's an API effect, I need to call this function. If it's a registry effect, I need to call this other one. So, kind of like just the rough shape of it for the get function would look like this. It's just an if statement. If it's this thing, then call this function. Otherwise, call the other function. All right, that's not too bad. But for the user, this is great because they now don't have to think about like, okay, what am I touching here? To them, it's just, all right, it's an effect, it's on or off. The set function would look very similar. Again, if statement, if it's this, call this function, otherwise call the other one. But it gets kind of a little bit more convoluted pretty quick. So typically, if you're calling set functions, you first want to see like, well, do I actually need to set anything? If it's already in that state, right, why bother? Why call that API? Why send this broadcast message? A typical construct would be, all right, let me get it first. Only if it's different, then I'm going to call the set. Okay, fine. I'll put it in there. Now I have two if statements. I guess it's still okay. But now I want to add what if support, right? Should process. You can kind of see what starts to happen there. It's going to get like nested. I'm going to get like basically code duplication. It's not a great way to organize this code. And we've only really talked about two types of effects, right? If we want to kind of future-proof this, if we want some kind of extensibility, well, what's going to happen if I have 3 kinds or 4 kinds? This is going to get really ugly really fast. So what if we used classes? So with classes, what I could do is I could create a base class that describes the general shape of an effect, right? It has a name, probably has a description. It's either enabled or not. And then I can create an inherited class that just describes, well, okay, for that particular inherited class, this is how you set it, this is how you get it. If I have that, then the function becomes very simple no matter how many different kind of varieties I have. As long as these all are described by this base class, I can handle them the same way. So I'm kind of hiding the specifics about how to get and set in my class, and then the function code becomes very simple. That make sense? Okay. All right, now we look at the actual code. We already looked at the signatures, and then if we look at the classes, I've defined some enums. They're really just here to make tab completion easy, especially if you're still supporting PowerShell 5. And here's that base class. So, take a look. Again, it's not a huge thing. It really just defines the base properties that any visual effect should have. A name, whether it's turned on or off, a description, and then the type. I use the type to basically indicate, well, which type of effect does this describe. I have 2 methods, a refresh method that just updates that enabled property, and a set method to turn things on or off. As you can see here, this is the base class, so it actually doesn't do anything. It's basically just a bunch of throw statements. This is because PowerShell doesn't really have a concept of what you have in some other languages, like an abstract base class or maybe an interface where you can describe, more of like the pattern of these classes. So I've kind of cheated. I think this is the best we can do. It's kind of like I've put in some placeholders. And then here's the first child class. So this is the one that describes the registry type of effect. I need some additional properties. I need to know what registry key I'm talking to, the value. There's a data on, data off, because some of these effects are kind of like inverted, like what it says in its description is the opposite of what the data in the registry shows. And then the broadcast, what type of broadcast does this particular effect need to send to take effect immediately, which I've just all discovered, right, basically from that previous exercise. The refresh method, very simple. We're just reading a registry item. The set method is also pretty simple. We're doing a set item property. At the very end there, you see we're handling these broadcasts. We're basically using another class to collect all of the broadcasts that need to be sent. And then once we're done, let's say that we've touched a bunch of them at the very end, we just say, all right, now send all of these broadcasts. It just deduplicates all of the broadcasts. That make sense? All right, and then the other one is actually not even that much more complicated. This is the one that uses the API. I need a different set of properties. I need basically that number, right, that the API requires, the SPI get or set number. But the refresh method, again, calls the API and then sets the enable property. The set method calls the API and just make sure that it worked. Yeah. Like I said, there's a few things here. So I actually discovered in the process that some of these, even the API-based effects, there is some variation. So like the animation effect needs some special properties. It needs like a struct to actually call this API. But hey, now this is great. So I've actually now used inheritance again to say, all right, well, this is a special case of one of these SPI effects. And here's how you describe that. So it becomes all very flexible. Here's one where it just flips the parameters. For some reason, it decided for this one you have to call the API in a different way. And you can see this visual effect SPI alt param, it only redefines the set method, because the refresh method is actually the same as its parent class. And then finally, there's just some extra code. I won't go into too deep into this one, but this is like that broadcast class that collects all the broadcasts and sends them as a method to send them all when we're done. The last part talks about a class factory. So this is like kind of a helper class that helps me generate instances of these particular classes. So it figures out like, okay, you're giving me some data that tells me what type of class I should instantiate, and it does that for us. The actual data that describes all of these is just stored in some JSON files. So if you look at the SPI-based one, the API effects, it's just a list, an array of the properties that I need to instantiate that particular class. This makes it very extensible, by the way, right? So this, I'm really just describing the code is in one place, the data is all in another place. So I could extend this with other settings if I wanted to. For the registry-based ones, it's similar, again, just a list of the properties that I need to instantiate that class. Any questions so far? Yes?
In your class definition, you had a hidden property, two hidden properties that were defined as PS objects, and the defaults were set to 0 and 1. Just wondering why you weren't setting them as bits or boolean.
Let me see if I could. Oh, so the question was there were some hidden properties in one of my classes. I think maybe this was this one. What? Yes, data on and data off. So in almost all of these registry typed effects, you turn them on and off by literally just writing a 0 or a 1 into that registry value, like as an integer or a D word. So that's the default. But some of them, they basically flip it around. To turn them on, you have to set a 0. To turn them off, you have to set a 1. I didn't make this up. But so this gives me the ability to basically say like, okay, if you don't tell me anything, I'll use 0 and 1 to turn off and on. But in that data file, if I specify a data off and data on property, you can basically flip it to anything. Like maybe it needs a string that says on or off. So this makes it just makes it very flexible. The only reason that this is hidden, right? It's hidden doesn't mean private or anything like that in PowerShell classes, but I'm using these classes also to display the result, which we'll see in a minute here, and I don't really need to see all of that. Was there a question from the back? Yes, right, exactly. So this basically allows me to take any type of value that a registry will take and use that. Okay. So we see how this works. Let me see if I'm actually on track with this. Yes, I am. So we can get rid of this guy. I think I mentioned I just published this on GitHub and the PowerShell gallery this morning. So if you want to run this, you can install module or install PS resource and get it from the gallery. So let's see what that gives us. So get visual effect gives me the current state of the machine. And if I want to set one of these, for instance, drag full windows. Let's see, do we have this on or off? Okay, so it's off right now. I can turn it on, and there we go. We get the full contents. All right, so that works. You can go crazy. You can say, all right, so pipelining works the way you would expect it to. you can take all of the effects and then call set with like a, let's say, an enabled true, and it turns everything on. I don't know if you can see it well on this screen, but when I just did this, there's a shadow around this box. You can see the icons at the top left have like a drop shadow. Things like the start menu, they kind of like fade in and out. I also added the concept of presets. So really that's a very simple bit of code that just lets me describe like kind of like a preset combination of these. I prefer this one. So again, look at the shadow, look at the drop icons, and they're gone. And now if the start menu goes in and out quite snappily. Yes?
So if I'm following correctly, if you type get-visual effects to get member, does it return the list of properties that can be modified?
Ah,
Looks like it should.
let's take a look. The question is, what if we type get visual effect to get member? What do we get? Anybody guess what this will look like? All right. Too much suspense. Hash table? It's my classes. Right? So there's a lot of these will have the same type. Get member, if it sees different types coming through the pipeline, will just describe each of them. And you can see, all right, so some of these were from the SPI class. That's actually most of them. And so they all have slightly different shapes, but because they're all based on the same base class, and I've hidden the properties that don't really matter, that's why I get nice output from this thing.
If you didn't hide them, you'd get like extra columns where some of them are empty and some of them weren't.
Yes.
Maybe you don't actually really care about.
The question is, if we didn't hide these properties, then what would it look like? It gets really gnarly, right? Because it depends on what the first object is. And if it has extra properties, it will display that and then use the same thing for all of the other ones. And that's just not going to look good.
Would it also actually, every time it changes, give you a new table?
No, if this is how just PowerShell formatting works. I think it always looks at the first object, will decide based on that what a format table would look like. Of course, if you pipe it to format list, you'll get all the properties for each object individually. So great. So that works. Anything I forgot to show here? Any questions so far? All right, let's wrap up. So what did we see? We've learned something about broadcast messages and how we can discover them and use them in our code. We've seen a use case for PowerShell classes to keep code nice and clean and extensible, future-proofed. And we now actually have a module that handles all of these settings. Like I said, the module is on GitHub as of this morning. So that's also a good place if you have see any issues with it, if you have any suggestions, file an issue there. It's a good way to collaborate on this. It's also on the PowerShell gallery. Just look for visual effects, and hope that's useful to somebody. Any other questions? Yes? The question is, are we utilizing? Yes, we are utilizing this in production. How? So we already have a system that runs scripts that configures user settings when they first log in, and actually even on subsequent logins in some cases. So this was actually pretty easy to just insert into kind of an existing configuration system for user settings. Yeah, for most users, we use that performance preset that kind of gives them the best performance. People can change it if they want to after the fact. So we're not enforcing it, but it's a good default. Any other questions?
For the performance preset, is that effectively mirroring what at least in Vista was the lie of that dialogue that said adjust for performance?
Good question. So the question is, what are these presets? How do they relate to, I guess, the original GUI settings? So if you adjust for best appearance, that's everything on. Best performance is everything off. The performance preset that we use is basically everything off except screen fonts smoothing. That's just, I mean, honestly, you can't live without that. Everything else you can live without. And then there's another one that essentially that only turns off all of the animations. But just to show what these presets actually look like, because they are very simple. So this performance one is really, again, just a list of an array that describes the name and whether that you want that effect on or off. So you could add more of these if you have other presets. They're easy to insert in the code here. All right, bonus round. There seems to be a very popular thing that people want to turn on and off that we've discovered in this conference. So
This is the lightning deck.
I was going to ask about this, but
what if you wanted to, if one of these settings required you to set 2 registry entries? Hang on, I will explain where this is going. There's a setting that requires 2 registry entries to be touched. Okay, so this is another version of the same module. I've just changed some slight things. I've made this value property an array of strings instead of just a single string. And I've just adopted this slightly so that it touches 2 registry keys instead of 1. And if I then add a little thing, there's 1 entry to my list of registry entries. Sorry, I had to do it. I did this last night. Set visual effect, light theme, false. Yes. I honestly don't know why that always gets the applause, but whatever floats your boat. Yes, sir.
Can we keep the taskbar up while we do it so we know Explorer didn't get killed in the background?
Okay. Oh, speaking of Explorer, do we still have time? I don't know. We have 3 minutes. Let me see how fast I can do this. This is probably a more useful version of the extensibility idea. So in the registry here, there's a bunch of other things that kind of show up in this same registry key. By the way, I didn't mention this, but I did add a JSON schema file, so I get tab completion, which is always nice, and also validation. The pester tests will actually verify that all my JSON files are in the right shape. So let's add this guy. I know you guys are hungry, so I'll try to do this fast. All right. Guess not fast enough. It's the same key as this one. Man, typing is hard. Especially when lunch is on the line. All right. Hopefully I did that right. Oh no, another comma. Oh, JSON. Why do you do this to me? Okay. All right, so I've added 1 entry. And I need to just add it in one other place, and that's my enums. All right, let's see if this worked. So over here, if I now import this guy again, Okay. You can probably guess what this does. So let's say I have my Explorer window here. This is the directory of my actual files. You can see file extensions are not visible, right? I have apparently 2 files that are called the same thing, according to Explorer. If I now take this setting that I just added and set it to false, watch on the left. There it is. And correct, no Explorer restarting. It's not necessary. Just got to get your broadcast messages in order.
You can, I imagine you can do the same for the system files and hidden files.
System, yeah, the question is about system files and hidden files. Yeah, really anything that you can set in the registry, right, you can touch with this. And you'll probably find, especially for those types of things, they are all associated with some kind of broadcast message. And so, yeah, you can add those on and make that easy. You can set nice defaults for your users. All right, thanks everybody. Please send some feedback. Thank you very much and enjoy your lunch.